This is a short video on how to calculate reverse percentages. Before we look at reverse percentages, it's going to be useful for us to recap on how to calculate percentage increase decrease using a multiplier. Let's say we want to increase £12,000 by 6%. Remember that 6% as a decimal is just 0.06. What we could do is just find 6% of £12,000 and then add that to the £12,000 that we had initially. However, a better and more direct way to do it is to use a multiplier. Let's think about what percentage of £12,000 we want to end up with. Well, we want 100% of the £12,000 that we started with. And in addition, we want 6%, which represents the increase. So together, we want 106%. So that's 106% of the original £12,000. As a decimal, that would be 1.06. So 1.06 is going to be the multiplier that we use to increase any quantity by 6%. So now let's apply that multiplier to the £12,000. So 12,000 multiplied by 1.06, which equals 12,760. So this is our £12,000 after our 6% increase. If instead of a 6% increase we wanted a 6% decrease, what we would have done here is taken away the 6% instead of adding it to give us 94% here and a multiplier of 0.94. If we wanted to use a multiplier in a compound interest situation, what we would have done is, for example, if we wanted to increase by 6% for 3 years, instead of multiplying by 1.06 here, we would have multiplied by 1.06 to the power of 3. Using a multiplier like this also helps us to understand reverse percentages, which we'll look at next. With percentage increase or decrease, we're given the initial quantity and asked to work out the quantity after the increase or decrease. However, with a reverse percentage question, what we're given is the quantity after the increase or decrease and then asked to work out the initial value. Let's look at an example of calculating reverse percentages. So Bob has had a pay rise of 4% and his salary is now £78,000 a year. But what was his salary before the pay rise? That's what this question is asking us. To answer this question, what we're going to do is form and solve an equation. We're going to form the equation from the information in the question and from what we know about how the new salary was calculated. The unknown in this question is the original salary. We know that the new salary, £78,000, was calculated by applying a multiplier of 1.04. So let's now write all that information down in the form of an equation. Okay, so the unknown is the original salary. So we'll use X to stand for the original salary. And we know that the new salary must have been calculated by multiplying by the multiplier 1.04. So the original salary times 1.04 equals the new salary. The new salary is £78,000. Okay, so X times 1.04 equals £78,000. So now we've got an equation which represents the information in our question, as well as what we know about how the salary was calculated. So what we need to do now is solve that equation by dividing through by 1.04, and that's going to give us x equals £75,000. Okay, and remember, x stands for the original salary, which is what we're looking for. So the salary before Bob had his pay rise was £75,000.